Okay, so here are some of the kind of extra examples if you're wanting to see these work through. If maybe you just tried them on your own and you want to check your work. So let's take a look. Okay, so this first one here, like always, okay, step one, like it always has been, is find the parent chain, right? Which is the longest chain of straight carbons. So I see 1, 2, 3, or 1, 2, 3, or 1, 2, 3. It actually doesn't matter. No matter how we choose that, IUPAC was very careful when making the system that you'll get the same name either way. Okay, if you don't believe me, you pick a different chain and see if you get a different name. Okay, all right, so there we go. There's our parent chain. How many carbons are in it? 1, 2, 3. So what is the prefix that goes with 3? Prop. Prop, okay, from page 9 you can check. Okay, now next thing we check for is any double or triple bonds. Well, I don't see any, I only see single bonds. So that tells us the ending, right? So single bonds only. And the ending, that means, will be ane. Okay. Last thing, so we've talked about the 3 carbons, that's prop. We've talked about the single bonds only, that's ane. We're just missing this thing, this big group here, this branch, okay? Now, how many carbons are in that branch? Just 1, right? So this would be methyl propane. Now, again, you could say 2-methylpropane. However, this is the only kind of methylpropane, so you actually don't need to say 2-methylpropane, right? How would you put this anywhere else? Because imagine if you put it here, well, that wouldn't be 1-methylpropane, right? That would now be butane, because you would, if you put it there, you've now added it to the parent chain. Okay, so this would be methylpropane. You could say 2-methylpropane. That wouldn't be wrong, but usually we would just say methylpropane. Okay, on to the next one. So here I see 4 carbons. Okay, what's the prefix for 4? It's bute. Okay, next thing, how's this thing going to end? Well, check for any double or triple bonds. Nope, single, single, single. Okay, so this is going to end in ane. All right, so we've covered the 4 carbons. We've covered the fact that there's only single bonds. What are we missing? Well, hey, look at this big branch that's sticking out. We haven't said anything about that. What kind of branch is that? How many carbons does it have? 1 carbon. So this would be, the kind of prefix for 1 is meth, right? So this would be methylbutane. So far, what have we said? We said that there's 4 carbons and no double or triple bonds. And somewhere there's a methyl group, a branch with 1 carbon. Okay, what are we missing is the where is that 1 branch? Well, it's either on carbon number 1, 2, 3, 4, or we could say it's on carbon number 1, 2, 3, 4. Okay, which of those is right? Should we say it's on carbon number 2, counting this way, or should we say it's on carbon number 3 if we count this way? Well, we should always give it the smallest number we can, right? So we should say it's on carbon number 2. So this would be 2-methylbutane. Big, long looking one. Looks scary at first, but then you realize, right, we're just going to follow the same rules we always do. Okay, so I'm going to find first the longest continuous chain. So I see here 1, 2, 3, 4, 5, 6. Let's just double check the other one's not longer. 1, 2, 3, 4, 5, 6. Okay, so it wouldn't matter. Either way, let's just make our lives a little bit easier then and do the nice, flat, easy looking one. Okay, so we have 6 carbons in that parent chain, right? We just counted, so 6, that's going to tell me like a hexagon, so hex, okay? Perfect. Any double or triple bonds, because that'll tell me how it ends. I only see single bonds, so if it only has single bonds, that means it ends in ane, right? Hexane. Okay, perfect. Now, what am I missing? What have I not said anything about? I've covered the single bonds. I've covered the number of carbons in the parent chain. I haven't said anything about this branch here, though, right? Okay, so with the hex, we've covered the 6 carbons in the parent chain. With the ane, we've covered the fact that there's only single bonds. So what's left? This branch, right? And so that branch has how many carbons in it? 1, 2. So what is the prefix that matches 2 carbons? It's eth, right? Eth. So this is ethylhexane, which just says that this is, well, hexane with an ethyl group on it somewhere. Where? Okay, question for you. Would we say that this ethyl group is on the 1, 2, 3, 4, 5? Okay, would we say that it's on the 4th carbon, or would it be better to say that it's on the 1, 2, third carbon. Would we say is it better to say it's on the fourth or the third? Well, we go with the lower number, right? So we should actually count this way. We should not count this way because we have to give it the lowest number possible. Okay, so we would say this is not 4-ethylhexane, this is 3-ethylhexane. Okay, looking at this one. So first things first, always find the longest parent carbon chain, right? Circle that. So we got 1, 2, 3, 4, 5. If we go this way, 1, 2, 3, 4, 5. Okay, looks like no matter what, it's going to be 5, right? We could even go 1, 2, 3, 4, 1, 2, 3, 4. Definitely 5 is the longest. Okay, so what does that tell us? So 5 carbons in the parent chain. That's going to give us pent. Okay. Any double or triple bonds? I don't see any. Single bonds only. Okay, so that means pent ends in ane, pentane. Now, we've covered the 5 carbons. We've covered the single bonds only. We got to think about branches. So we've got 2 branches, and each of them has 1 carbon. Okay, so these are 2 methyl branches, right? It's not 1 ethyl branch. It's 2 methyl branches. So that would be dimethyl, right? That just means there's 2 methyls somewhere on here. Where are they? Well, they're either on carbon 1, 2, 3, or carbon 1, 2, 3, 4. Okay, so either 2, 3, or 3, 4. We should definitely go with 2, 3. Okay, so this would be 2, 3 dimethylpentane. Okay, looking at this one. Longest carbon to carbon chain looks like that one, right? 1, 2, 3, 4. Okay. So 4, what is the prefix that matches 4? What's the beginning? 4 is butane, or well, bute. Okay. For the ending, like I just got ahead of myself there, is it going to be ane? No, because look, we have a double bond here, right? The only way it ends in ane is if there's no double or triple bonds. So that's a double bond. What's the ending that goes with a double bond? Ene, right? Ane. So ene for a double bond. Now we have to say where the double bond is. So remember, we always number the carbon chain so that the double bond gets the lowest possible number. Now you're saying to yourself right now, but there's also a branch, and we try to give the branch the lowest number too, right? But only if there's no double bond that takes priority. Okay, so we have to give the double bond the lowest number. Doesn't matter if that means giving this a higher number, giving the branch a higher number. Okay, so this end is where we're going to need to start. So 1, 2, 3, 4. Okay, and now that's locked in. That's carbon number 1, 2, 3, 4. We're not going to change it when we go to number the methyl branch. So we have bute. Where is the double bond? It's on carbon number 1. So bute 1 ene. Okay, and well, there we go. We've covered all that stuff, right? We've covered the fact that there's a double bond with the ene. We've even said where it is with the 1. And we've covered the fact that there's 4 carbons in the parent chain. So now that's all that's left to do is talk about the branches. So there's 1 branch and it has 1 carbon. So that's definitely a methyl branch. Okay, we don't need to say di or tri because there's only 1. Methyl bute 1 ene. And what are we missing? Where is the bute? Well, we've already numbered it, right? We can't switch it now and go 1, 2, right? We're locked in once we do this. So that is the 3rd carbon. So this is 3 methyl bute 1 ene. That's catchy. Okay, here's a line diagram with a branch. So we could say 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is the parent chain. It's longer. So there's our parent chain, which means this is just a branch. Okay, so 8 carbons in our parent chain. That makes this oct or something, right? But we know there's 8 in our parent chain, so oct. Okay. Next thing, the ending. Are there any double or triples? No, there are not. So this is just going to be octane. Okay. Finally, all we haven't talked about is this branch. Now notice, be careful here. There's not 3 carbons in this branch, right? That carbon is part of the parent chain. So there's only actually 1 there and 1 there. There's 2 carbons in the parent chain. So this is going to be, what's the 2? Well, that's eth. So ethyl octane. And all we have to do now is say where the ethyl branch is. So again, always 2 options for numbering. We can start left and go right, or right and go left. Let's see. If we start left and go right, 1, 2, 3, 4, 5, 6, 7, 8. If we start right and go left, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so notice when we start right and go left, which I've done on the bottom here, this branch would be the 4th carbon. If I start left and go right, which is the top here, I get the 5th. So which one should I use? I should use the start right and go left one. Make the carbon that the branch is on be number 4, not number 5. So 4-ethyl octane. Okay, and there we go. We've named all of them. All right, now drawing again, a little bit easier actually, because they can't trick you, right? They just tell you what's going to be there and you go ahead and draw it. So 2-methylpropane. We'll start with number 1, obviously. 2-methylpropane. Okay, so 2-methylpropane. Well, break it down. Always start with the parent chain. Okay, just like we always have. Prop. So that means 3 carbons in the parent chain, right? So C, C, C. There we go. We've dealt with prop. We've shown prop. Ane. Have we shown ane? Well, ane means no double or triple bonds, single bonds only. Have we showed that? You bet. Right, that was easy. Okay, 2-methyl. So we have to show that on the 2nd carbon, there is a methyl group. So on carbon number 2, there is a methyl group. A group with 1 carbon, a branch with 1 carbon. What's left? Have we dealt with everything? Yep, right, that was the last thing we had to deal with, so everything's dealt with. That means all that's left to do, fill in the hydrogens. Okay, just make sure every carbon has made 4 bonds, but there we go, 2-methylpropane. Again, that's the one that we usually just would call methylpropane, because there is only 2-methylpropane. You can't put the methyl anywhere else, but oh well. Okay, 4-ethyl heptane. So let's break that down. What do we start with? The parent chain. Hept. Okay, so that's how many carbons? 7. Okay. Ane. Again, that makes our life easy. Ane, that means single bonds only. Boom, done. We did the hept, we did the ane already. All we got to say now is 4-ethyl. So on the 4th carbon, okay, there is going to be an ethyl group. What does eth mean? Eth means 2 carbons in it, right? So on the 4th carbon, 1, 2, 3, 4, there is an ethyl group. So C, C. There's the 2 carbons, okay? That is an ethyl group now, as long as we remember to fill it in with hydrogens. So have we dealt with everything? We did the 4-ethyl, we did the hept, we did the ane. Make every carbon happy now with the amount of hydrogens it's missing. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, let's just H2 it, 1, let's just H3 it, okay, 2 for you, 2 for you, 3 for you, and there we go, everyone's happy. 4-ethyl heptane. Okay, number 3, 2,2,3 trimethylpentane. 2,2,3 trimethylpentane. So start with parent chain. Pent, pent. Okay, so pent means how many carbons in the parent chain? 5. 1, 2, 3, 4, 5. Okay, pent, done. Done like dinner. Ane, ane. You tell me, have we done ane? What does ane mean? Right, it means no double bonds. Good. Okay, no double or triple bonds. It means single bonds only. Good, we showed that already, right? These are all single bonds. Okay, now 2,2,3 trimethyl. Intimidating at first, but all that means is, first of all, trimethyl. What does that mean? It means there's 3 trimethyls somewhere on this thing. When I say somewhere, you say, but where? And we say, oh, right, 2,2,3. That tells us where they are. So there's 3 methyls, 1 on the 2, another 1 on the 2, and then 1 on the 3. Okay, so 1 on the 2, CH3. Now don't stick it onto that one, because then this wouldn't be a methyl anymore. It would be an ethyl, right? But if we stick it down here, then there we go. That's 1 methyl, that's 2 methyls. So 2 2, 3. That's 1, 2, 3. That's trimethyl. There we go. Okay, so we've done the 2, 2, 3 trimethyl. We've done the pent. We've done the ane. All it's left to do, fill in the hydrogens. Make sure every carbon's happy. And there we go, 2, 2, 3 trimethylpentane. All right, number 4, 3-ethyl, 4-methyl octane. So as always, break it down. Parent chain first. Oct. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, oct. Done. We've dealt with it already. Ane. Again, what's that mean? Single bonds only. So didn't have to do anything. We did it by accident almost. Okay, 3-ethyl, 4-methyl. So let's do 3-ethyl first. Okay, 3-ethyl. So on the third carbon, there's going to be an ethyl group. So 1, 2, 3. Ethyl means how many carbons in the group? 2 in the branch, right? There's going to be 2. So 1, 2, 3. On the third carbon, there's 1. There's the second one. Okay, there's the 3-ethyl. Check. Done. What about the 4-methyl? Well, that means on the fourth carbon, there's going to be a methyl group. And meth means 1 carbon, right? So on the fourth carbon, there's a branch with only 1 carbon on it. So that was our third carbon. Here's our fourth. So CH3. Whoops, got ahead of myself. CH3. Okay. So now we've dealt with the 3-ethyl. We've dealt with the 4-methyl. We already dealt with the octane. What's left to do? Just fill in the hydrogens until every carbon's made 4 bonds. Okay, number 5, 2-methyl-pent-1-ene. So don't get overwhelmed. Start with what you know, right? Because it's always the same process. We build up our base chain, and then we kind of stick pieces on where we need to. So pent. So pent means 5. 1, 2, 3, 4, 5. There we go, right? Not so bad so far. Pent. Good, we dealt with that. Check mark. Pent, done. 1-ene. Okay, what does the ene mean? Ene means double bond, right? Ane, ene for single, double, triple. Okay, and the 1 just tells us where it is. So on the first carbon, there's a double bond. That's easy enough. First carbon has a single bond now, just make it a double. There we go. Right, not so bad. Pent-1-ene, boom, over, dealt with. Pent-1-ene, boom, over, dealt with. What about 2-methyl? That's all we're missing. So there is a methyl group, which means how many carbons? What does meth mean? 1 carbon, okay, and where is it? Where is that methyl group, that 1 carbon branch? On the second carbon. So on the second carbon, we need to add a branch that only has 1 carbon on it. So on this second carbon, we're going to add a branch that only has 1 carbon on it. There we go. Now we've dealt with the 2-methyl, we've dealt with the pent, we've dealt with the 2-ene. All that's left to do is give it the hydrogens it needs to have every carbon be happy. Ooh, careful, I almost made a big mistake there. Careful, this carbon's making 1, 2, so it only should have 3, 4, right? Okay, what about this guy? 1, 2, 3, 4. Does that carbon need any hydrogens? No. But this guy, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Whoops, I forgot to give this guy his hydrogens. So there we go. 2-methyl-pent-1-ene. Dunzo. Okay. 4-ethyl hex 2-ine. So hex 2-ine. And the ethyl, I'm just going to highlight it all now, and then we can go back and do it. 4-ethyl hex 2-ine. So blue for hex, that tells us the parent chain. Hex, what's that mean? That means 6 carbons. So 1, 2, 3, 4, 5, 6. Okay. The ine, what does that part tell us? That tells us the double bond on the second carbon, right? So on the second carbon, 1, 2, there's a double bond. Oh, sorry, ine. Ine means triple bond. Triple. Listen to me. Triple bond. There we go. Okay, fixed. So we've dealt with the ine, the 2, right? So we dealt with the hex 2 and ine. Okay. What's left? Well, 4-ethyl. Okay. So 4-ethyl. So 4-ethyl on the fourth carbon, there's going to be an ethyl group. So 1, 2, 3, 4. What does eth mean? How many carbons? What does it say on page 9 of your data booklet? It says eth means there are 2 carbons. Okay. So this would be a CH2 to make it happy. That would be a CH3 to make it happy. Okay. Have we dealt with everything in the name? You bet. So fill everything in with hydrogens. 1, 2, 3, 4. Look at these guys. They're already happy. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So the general idea, folks, when you're naming and drawing is just take it apart. Say, have you identified everything in the molecule that's interesting in terms of the carbon? So have you identified every branch, every double bond, and the number of carbons, right? Same goes for when you're drawing, but backwards. Have you taken every part of the name, okay, and addressed that? And then once you've addressed it, just fill it in with hydrogens, right? Notice that nothing in this name is useless information, right? 2-methyl, that's important. It tells you there's a methyl branch and where it is. Prop, that's important. It tells you how many carbons. Ane, that's important. It tells you how the bonds are put together, okay? There's no such thing as a useless part of the name of a hydrocarbon, okay, for either drawing or naming.